We're continuing the build of our Seagull Models Gilmore Redline. Let's go. The next step, we're going to go ahead and we're going to set the tail in the back of the aircraft. This is the step where it's important that we have the marks on our elevators. So the marks match the horizontal. Remember, we did that back at the very beginning, because we want to make sure that the area that our horns are going to go on the bottom. So this piece is going to sit, it almost clicks into the back of the fuselage. It's a very nice fit, but we still need to make sure that it's parallel and perpendicular in the fuselage. Let me take you off of there and show you an up close and personal how we use the string to do that. Our first steps, what I'm going to do is I like to make sure that my fuselage is going to be level in both directions. So we're going to make sure that it's level side to side and front to back. All right, that's when we're going to use our laser to reference the tail, and we'll show you that in a little bit. Now, in the very center of the fuselage, I'm going to take this stringer right here that goes up through the nose, and I just put a T-pin in there, and I loosely attach a piece of mason's line. That mason string we're going to take all the way back, and I have a piece of tape that's on there lightly, so I could slide it back and forth the string. We're going to take this thing, and we're going to bring it all the way to the corner of the tail, and we're going to mark that just like that with that piece of tape. Now we flip over here to the other side, and that string will pivot nicely on that T-pin, and we check to see if it's the same distance. If it's different from side to side, we want to take that tail and pivot it in here to make sure that it matches. So it may need to go this way or this way. The other thing that may happen is we need to slide the whole tail left or right. So we want to make sure, using a ruler, that that measurement from the edge there all the way over to the edge of the horizontal is the same side to side. So let's go ahead and we're going to get that set into place, and then I'll go off to the next step. Tail is set into place, so we have our mason line set up that we have the same measurement there to the other corner. We've used our ruler from here to there on both sides, and we've made a mark on the back side, so we know that all of that is good this way, and we know that it's good this way. So the question is it level side to side? Is the saddle built correctly? So we use the handy dandy, it's a laser. So we shoot that right across. I love the way that this thing is setting in there. Again, if you need to fine tune, you can do that with a little bit of epoxy if you want, or a little bit of sanding, either way, but this one sits really, really nicely. Good job, Seagull Models. You've done a great job with another great ARF. So that sits in there perfect. Now what we're going to do is and you can also look across this to make sure that this sits right with the wing and the wing tube up there. So when I look over the back, I can see the wing tube is the same distance on each side, height-wise, that it's not, none of this is tilted this way. So that's awesome. The other thing is, now we're going to go ahead and use the heating iron. We're going to seal off the hinge areas, and we're going to seal over the tops, and we're going to mark this underneath. I use these things, they work out great. Go underneath, make yourself some lines, and then we got to cut some covering. The tail, we can do the same thing up top with the vertical. So we take this, we're going to set that into place, and we are going to go ahead and take this thing and mark it. Like so. Now I do not want to cut right on that line. I'm going to cut in on that line. So we'll take that off. All the marks that I made up there are still all in the same spot and location. Nothing's moved on me. So we're going to take this underneath. There. And there. All right. Time lapse. When you go to cut the tail, you want to make sure that you use a nice sharp X-Acto knife. I like this brand a lot. Something I just picked up off of Amazon because you can snap the ends off of this. You can change the blades out in a regular one as well, but make sure that you don't use too much pressure. Again, we've used the heating iron to press all of that in first. Then we go ahead and cut out. And remember, we've saved these pieces because these can be used for repair pieces down the road. A little bit of red, a lot of white if you poke a hole or something, and obviously it's a perfect match without you worrying about where you can obtain covering. So that's a great little tip for you. All of this wood is exposed here now, and we're ready to put this thing in. We have all of our marks lined up. This is where you want to double and triple check all your measurements, make sure that everything is good and right. And before we throw the epoxy into that, we're going to go ahead and reuse our laser, and we're going to set up the tail because the tail is just epoxied on as well, the vertical. So that thing is going to go up there just like that. We're probably going to throw some rubber bands around that, but we're going to shoot our laser because we know that our horizontal is good. So with a floating laser, the vertical should be straight on, and we can make sure that it's good with our T-pin up there. So let's go ahead and get all of this lined up and epoxied into place. All right, so let's do something here. We're going to take this off. To help us hold all of this together, we're going to take this tail apart before we throw any epoxy on, and we're going to take a couple rubber bands here, and we're going to slide this all the way up and over right there. So that's going to help us get everything secured after we have the tail on. So watch what we do here. All right, tail's in. You could see what I did with the rubber band. So that's going to keep tension down. That's going to help to keep my horizontal squeezed into place. It's going to help to keep my vertical squeezed into place. And we have rubber bands around the back to keep everything lined up. And as you can see, we've shot the back with the laser. So everything there is square and perpendicular. Now it's just time to let the epoxy do its work. All right, our vertical and horizontals have sat overnight and are fully cured. In the epoxy, these will just cut off. So those are trash. Check that, it feels nice and stable, secure. I like it. All right, now we're gonna go ahead and we're gonna glue in our surfaces. So we're gonna go ahead and install those hinges and get those set into place on our rudder and our elevators. So let's do that. Again, just like we did on the front, on the ailerons, if you didn't see that section, we're going to take little push pins and I put them in the center of these. They're called fiberglass hinges. We have fiberglass hinges, nylon hinges, robarred hinges, and they're all very uniquely different to install. But fiberglass hinges, you just use thin CA to wick that stuff in there. Or use thin CA to wick into the hinges and it holds it. Some people will put crayon marks in the center, and that is to keep the glue from really wicking in there. I've never really liked that theory. I'm okay with the glue wicking all the way through, even in the joint itself, but I do put those in there, and I put 2 so that way I know that they're in straight and that I know that I have an equal amount of material on both sides, which is really important. And as I did with the ailerons, I like to do the bottom side first, and that's because they tend to wick up more glue, so you're less likely to have a run. And then from the other side, I'll do that after, because if you have a drip that goes through underneath where you've put in too much, well, then it's underneath the plane. No one's going to see it anyway. So there's our elevators again. Our numbers are up there, so 1 for 1, and we'll just slide that into the right spot. And when we do that, we're going to make sure that we keep everything lined up. And you want to make sure that the surfaces are the same side to side, but also make sure that your elevator halves will not rub on your elevator or the fuselage. So we want to make sure that we get this slid in, goes right into those grooves. Again, we've already taken the heating iron, so all those surfaces are melted down and nice and tight before we glue stuff in. And those little pins will give a track for the glue to go down into. Plus, it gives you a little bit of spacing, just a little bit. And now we'll do the rudder. Don't forget your rudder. So after we get these all glued in, the next thing we're going to work on is fiberglass control horns. And we'll get all those epoxied into place. It's pretty tight. If you do have issues getting these to line back up, you can always just take your X-Acto knife and work that slot back open again. And our last one, that one's a little foobarred. Foobarred is a northeastern term. In case I'm okay with fiberglass hinges, they hold up well. Depends on the size of the model. We're just going to slide that razor knife in there and really get that opened up some more. And one of the reasons I like it is because if you do it right, that CA wicks in there and actually seals that surface back up again. So it really kind of laminates the wood together. Alright, now let's get this thing rolled over and get all of our hinges glued into place. So if you guys haven't checked these out, I'm using the Fly-Rite RC stand, benchtop stand here to do this project. And as you've seen right there, all I had to do was turn the jacks to get this thing up in the air, which is really, really nice. So I can get this rudder hinged and glued in. We'll get you kind of turned there so you could see. But I use my body weight to hold this thing in place. We'll go ahead and glue in those hinges. It's time to put in our elevator horns. You could see we already remember we did at the beginning. We got holes drilled and we got both sides of those sanded. So we just like to make sure that we like to fit. Yes, I like to be picky. I like the holes on the hinge line. Big discussion recently on Facebook about that stuff. Does it matter? It does. Do we notice it? Probably not. Are you good enough, pilot, to notice it? Probably not. Do I like to build stuff just no, not really. I like to make things as right as I can make them for a lot of reasons, and I know what right is, and that's what I want to do. And if it makes big enough difference, fine. If it makes no difference, well, that's okay. So once that horn is there, I just go ahead and tape that off so I know what area I'm going to work within. Time to install our tail wheel. You're going to need that piece for the flying wires first. We are going to find our tail wheel, and that goes in these two more aft holes. These are 3 mil by 15, and I'm going to dry fit this, and I'm going to show you why. It's going to help you with the placement of this thing so it doesn't rub, because we are going to have springs that attach to here back to our tail wheel. So when we use the rudder pull, this thing goes with the rudder, and that spring tension will move the tail wheel. But you don't want this so far forward that when we turn, it binds on the tail wheel, especially during landing. So we're going to creep this thing back a good bit, and that dry fit is going to help us to find that location that works for us. I like that. Once we have that centered, we will pre-drill and we will soak that thing with CA, so that way those screws won't pull out of there. So let's take it back apart. We're going to mount that in with a couple holes, soak them with CA. We're going to put thread locker on those, and we're going to get some springs installed. All right, my tail wheel assembly is installed, and what I've done is I've just bent the springs here and folded them over. They're not permanently wrapped, so that way I can make fine adjustments once we start doing ground testing. So from there, let's go ahead and start getting all of our push rods installed for this aircraft. So whether we do them from this way or that way, really your preference, but let's get those installed. We've gone ahead and pulled the clevis off of one end so we could fish these through. The elevator will be on the outside, and those just get wiggled through. We'll spin off another one. And that will be for that side. And our rudder is going to be a pull, so we won't have anything there. Now, anytime you're using a metal clevis, you have to use jam nuts. And the reason we do that is not so they don't necessarily spin loose. Depending on how you have yours set up, it could. But you don't want all the tension put on the threads where the stress is going back and forth with the threads. And you always want to thread these so a little bit of the thread sticks out of the clevis. So for now, that'll be okay. That's where we want that one. We'll do the other side. And after we have our final adjustments, then we tighten those up. You don't really have to use a jam nut with plastic or the Dubro monster links or things like that. And I've seen people do it. If you want to, it's fine. It's not hurting nothing. Kind of looks unsightly, but you don't need it. But if you have metal and metal, you also don't like any of that frequency from vibration, that type of stuff. So that stuff does matter. And as always with clevises, you want some type of safety retainer. So whether you use these little pieces of Tygon tubing or guys use heat shrink, all those work. I want to go ahead and just quickly show you my choke linkage. I made a Z-bend, if you could see that right there, routed it underneath the throttle servo. They do supply you with a couple of these for just such a case, but I use the end of popsicle sticks, and I routed mine. Get that out of the way, and you can see my little choke rod right there. I'll probably put a piece of plastic on the end of that, but that's run through the little popsicle sticks inside. But that way you guys can see there, I can just manually open and close that, and it'll be just fine. That works really well. And it's routed in a Z around my tank, so it's not rubbing. But choke is installed, elevator linkage is installed. We'll start to hook up our receiver next, get some power to that, and start making the surfaces come to life. And we still have flying wires and such to work on as well. But we're getting there.
Traditional tail, one servo for the whole elevator setup, and one servo for the rudder. Now this is asking us which switch we want to assign to each of these functions. For today, we're gonna stick to the simple, quick mode of the jar, which is what most people...
So before we get too far into the next part, there's a couple things that we have to discuss. Number one is I've taken the time to go through and properly set up the FrSky receiver because I am using the Pt.4, so the stabilized 10-channel receiver in this model. This does take a little bit to get set up and set up correctly, so I am going to link down in the description the video and the files that I use to properly go through the setup, and I don't need to show you that because they've already done a great job. One of the things in my transition over to FrSky that I've so far absolutely loved is the resources that are available, unlike a lot of the other radio systems that are out there that I've used prior. It's kind of difficult to find the material, the YouTube videos, the help that you're looking for. With FrSky, there's been none of that. The information out there is in plethora, so no issues finding exactly what it is that you're looking for. So we're going to get to getting this installed. All of our servos, we're going to work on getting our linkages set up, making the wires so we can start to tidy up and finalize some of the controls on the inside of this plane, because it's getting pretty close already. So not a real difficult model to put together, but definitely some steps with learning new things that we have to make sure we do right. So let's start to the time lapse, wires, servos, receiver installation, all that cool stuff. Let's go. All right, sometimes we run into scenarios when we're building that you're not quite sure if the elevator is lined up with the horizontal. That's one of these because this airfoil is pretty tapered. It's round in the middle, so it's kind of hard to see. So while we're setting up all that elevator linkage, I level the fuselage, and then I use my handy dandy laser, and we make sure that the laser hits the center of the horizontal, comes all the way back through, it's level, and then it hits right out through the elevator itself. So right there we know that everything's going to be perfectly in line. And now what we'll do is use some carbon rods on this one taped back to the other one, so we make sure all of our travels are the same and our neutrals the same, and I'll show you that as soon as it's done. All right, we've gone ahead and we've installed low rates, medium rates, high rates there on a switch. We've used the carbon rod here taped to the tail, and then what'll happen, we go to high rates, we should get that traveled together, and also same at the top and the bottom. So we use the laser, we set this one straight, we referenced this one to this one, and then we used our throw gauge there to determine how much, and then we made sure that the travel matched up and down. So when we eyeball this now from the back, and you just do this and you watch that, they travel really, really well together. So now we know our elevator and our linkage is set up straight. Let's go ahead and get to the pull on our rudder. All right, this is the Seagull Models Gilmore Redline racer. We are working on the pull, and I wanted to show you guys how I do it. You will notice that there's a couple packs of flying wires. There's only one pack that has 2 wires in it and a couple ends. That's the one we want. It does come with some ferrules. You'll notice the size on these are pretty small, and then I have some bigger ones that I've picked up throughout different hobby places, hardware stores, or whatever. So a couple ways to do this. We're going to go ahead and we're going to take our turnbuckles about midway. We're going to take our wire, thread it through the ferrule. Does not matter what side. Going to thread it through here. And we're going to push back down through the other way. We're going to give it a nice little loop on the end, not too big, somewhat streamlined, so that way it's not walking too much on us there. You will see some that comes out the end. And from here, you can go ahead and crimp this. I highly encourage you guys to pick up a pair of cable crimping pliers. You can find them in many, many different places, but this is what you would use to crimp those ferrules in a couple spots. Do not use diagonals to do this because you will wind up cutting it. From here, I would slide up a piece of shrink tube over the end, and I would cover that up and make that look really nice. The ideal situation would be to take something slightly larger, thread it through that ferrule, around, give yourself plenty of extra cable. Here, get that same style end to it, and now we're going to loop this end back through again. So you're making a second loop, and we pull this nice and tight all the way around the side of that ferrule. So it looks like that. From here, you can go ahead and crimp your ferrule, again using your tool, and then slide your shrink tube over the end. The reason I prefer this method is because it's not going to pull loose. Sometimes as we transport models, we bang rudders around or grab a flying wire or normal flight, they will start to stretch and pull through that ferrule and develop a little bit of slop. This way, all it's going to do is increasingly make itself tighter, and it's not going to come loose. But you typically can't do that with stock ferrules. They don't give you enough space on the inside. If you wanted to run something through there and open it up, you can. It's not really worth the aggravation. Find yourself some bigger ferrules and use those. So I'll show you what the end product looks like. I hope that helps. And there you go. There you can see a nice finished, clean looking flying wire. All right, we have our rudder servo powered up. So everything is hooked up front. That rudder servo being powered will keep tension. Now we have our cables in the back. And here we have to install everything first. So that way we don't forget anything. So by that I mean like all the pieces we did later on the other end you have to do now. So you put on your shrink tube, you put on your ferrule, and then we're going to go ahead and slide this end through, and we are going to attach this right up into there. So we're going to put the clevis up on the horn. Now with straight pull cables, so I mean by that I mean not crossed, you can use a straight arm. If you're crossing your cables, you have to use an offset arm. You want to measure the distance from the hole here to the hole there, and ideally your rudder servo should be exactly the same distance apart where you hook up, so that way all your geometry stays the same. So now that that end's on, we're going to get all the pieces put on our other side. Shrink tube, ferrule, pull, clevis, and we're going to get this one snapped on. All right, now what we want to do is we want to go ahead, get the shrink tube out of the way. We're going to pull these tight, make them snug until our rudder is centered, and then we're going to crimp them down. All right, now we're going to go ahead and make our harnesses where we need to throughout the plane. I'm starting with the ones for the ailerons. So I cut myself the appropriate length section wire. We're using 22 gauge here. The wire, the reason I do this is basically so I don't have any extra weight in the plane, any extra mess I don't need, and it just never seems like extensions are the right size, but for a lot of people they work fantastic and there's nothing wrong with that. So for me, I use the Hansen Hobbies polarized connector ends where I'm going to be clipping and unclipping a lot, like in the ailerons, right? So when we take the wings on and off. I don't want to have to use servo locks, so that's why I choose to use those. On the other end, I typically use color-coded connectors going into my receiver, so I know what it's for if I ever have an issue to chase down later. And for me, I use red right. That seems to make sense. If you're looking at the lights of a plane, that's not correct. Somebody once taught me a long time ago with lights, red right return, and then you know the orientation of the plane, and that makes sense, but not all planes have lights, so that's why I just stick with red right for me, for my stuff. But anyway, I already have the other one cut, so we're going to time lapse through this and just show you a quick making of a harness. All right, and there's both of our aileron leads completed. You can see we have a red and green, and then we have those two ends there. I always use these as well. They really help me to see the pins, so that way I know that I have everything fitted correctly. So we have our locking extensions completed now for the wing. Seagull was nice enough to go ahead and put chase wires through the wing for us, right there. So what we're going to do is we're going to pop that thing off, take our tape out. Again, remember how we mark those, so that way everything stays together. So we're going to clip these in. All right, so that's locked in now, and we're going to take our string, get a little piece of tape, nice, and see, now we can go ahead. I've already centered that servo, so while I'm here, we'll go ahead, because I've already centered that servo. If I can hold on to it, we'll get the screws in there. Again, we're using King Max servos in this project. I've used them in several of my aircraft. I actually really like them. I think for the price, you can't go wrong. So let's go ahead and throw in servo screws. Pull off of our tape, all of our markings. And then once we power this servo up again, once the plane is put together, we'll be getting close to CG, and then we'll finish the linkage on our ailerons. But again, you can see there how I use that locking connector. All right, that's it. Let's do the other. All right, we're going to go ahead and throw this linkage on. And again, just a reminder, we always use the little silicone tubing holders over clevises. And you always, if you have threaded rods, you always use jam nuts, because you don't want that slop in the threads always getting pulled on. That creates flutter. It will also create wear, and eventually they pop off. So lock nuts, clevises, always. Lock nuts, silicone on the clevis, always. And I really like the hardware that came with this. This is 3mm rod, which is actually really stout for this plane. So I'm really glad to see that they're putting some good hardware in with this. We're pretty centered there. So this is our right wing, so right control, it should go up. So we're gonna have to reverse that. So there's right up. And looks like we're gonna need to get a little bit more throw into that one, but I like it. I like it. So let's get that pushed up on there, up onto there, and make sure we get our jam nuts nice and tight. Okay, there you go. All right, for the wing hold down bolts, they give you little bolts to put in there. If you're going to put those in, at least put a rubber backed washer on there so they don't vibrate loose. But I hate dealing with tools, putting wings on, so I want to use thumb screws for this. So what I'm going to do, my buddy Ronnie showed me how to make these a long time ago, and it's the best thing ever. So you cut a spacer. I got a much longer 4mm bolt. We're going to go ahead and put that through there. And then we got a cap screw for a 4mm hex head. This is from McMaster-Carr, and it's nice. You can get them in all kinds of colors. So what I'm going to do is put a drop of epoxy in there, a drop of epoxy on there. We're going to put that on, put that there, put another longer spacer here, and then I'm going to compress all that in a vise so that way it pushes this cap on, and then I'm going to take that off. So what I'm going to be left with is that. So epoxy underneath, little epoxy in the cap, and I mean just a touch. Press it, and then I'll show you the end result. All right, and there you have it. Thumb screws complete. So now I can just take those over to here, put them in. There you go. Check that out. So cool and so much easier than using tools at the field. And there you have it. That's a wrap of this section of the builder assembly of the Seagull Models Gilmore Redline. If this model interests you, do me a favor, head on over to www.gator-rc.com. You could find this model there, and maybe if this isn't your cup of tea, you could check out the full line of other products they have from Top RC Model, obviously Seagull's Models, and Sebart, or many others, as they are a full one-stop hobby shop for all your engines, transmitters, radios, motors, servos, everything you can imagine you will find there. So obviously, link down in the description below. You'll find all of the listings there of all of the products that we are using on the inside of this build. I appreciate you guys watching and following along. Smash that thumbs up. It helps us a lot. Like, share, subscribe, all that happy jazz. And don't forget to smash that like button. Head on over to Facebook and check out the Just Plain Crazy as well as the Gator RC Facebook pages. As well as YouTube and Instagram and TikTok for just the Just Plain Crazy side of things. But that being said, I appreciate all of you guys watching. I will wish each one of you happy flights. Peace out.